Hello guys, welcome back to my channel. So the topic for today is the same. We are studying statistics. In the last video studied about measures of central tendency, and this time we would be studying these are measures of central tendency, and this time we will be studying measures of dispersion. Okay, so let's begin. So first, in central tendency, we have three measures of dispersion. The three measures of dispersion are range, which is basically maximum minus minimum. Range, it is, for example, if we have 1 to 11, the range would be 11 minus 1, which would be 10. Okay, and the next is interquartile range, and the third type, that is the important one for this video. And interquartile range is another slightly complicated thing, and I will make another video for interquartile range. Okay, so the third type is standard deviation. Okay, so standard deviation is basically how much a value differs from the mean or average value, you can say. Okay, so I will explain this by a question. So let's say that we have workers and frequency. I'm sorry, this is x. X is the salary paid to workers. Okay, so let's say that the salary paid is 1, 2, 3, 4. This is for just for some simplification. You could also write 1000 or something, but I am using a simplified form of data. Okay, so let's say the frequency is 3, 7, 5 and 5. Okay, so here we have we can interpret this data by saying that 3 workers earn $1 or 1 rupee, whatever you want to say. 7 workers earn $2 or rupee, and 5 workers earn 3, and then 5 workers also earn 4. 5 other workers basically. Okay, so the formula for standard deviation, let me write it over here. Standard deviation's formula is square root of sigma fx square over sigma f minus x square. This is mean of x. All right, so for to calculate standard deviation, we would need first of all fx square. Okay, sigma basically means the sum of, as we discussed in the previous video. Okay, so fx square would be this we will first square this thing, which is 1 square equals 1, and then we will multiply it by 3, which would be 3. Okay, similarly 2 square 4 times 7 28, 3 square 9 times 5 45, 4 square 16 times 5 80. Okay, so that is it. And for we have to calculate sigma of f of x square. Okay, note that the square is only above the x, so we only square the x term over here. Okay, so f of x square, then we will calculate sigma, which is 3 plus 28 plus 45 plus 80. You can calculate it on your own, and the answer would be 156. Okay, and the sigma f would be equal to 5 plus 5 10 plus 7 plus 3 20. Okay, and now we have this thing and we have this thing, but we don't have this mean. Okay, for the mean of data, what we will do is that we will have to calculate fx. Okay, because that is the formula of mean that we discussed in the previous video. Okay, fx, so fx would be 3, 7 times 2 14, 5 times 3 15, and 5 times 4 20. By the way, I am multiplying these two values, 4 times 5, 3 times 5, 2 times 7, like that. Okay, and now we will have to do sigma of f of x. I will just write it underneath over here. sigma of fx would be equal to 3 plus 14, 17, 17 plus 15 plus 20, and it would be 52. Okay, so for the mean, what we will do is that for the mean of the data, we will divide 52 by 20, because that is the total number of workers. 20 is equal to x, the mean of x. Okay, so 52 over 20 is equal basically 2.6. okay, so the mean of x is 2.6, but for this formula, according to this formula, we would require x square. Okay, so we will square this value of x, the mean square would be 2.6 square, and that would be 6.76. okay, now for the standard deviation, what we will do is square root sigma of f of x square. Sigma of f of x square we have over here 156 over sigma f, which is 20, and then we will subtract it from the square of this mean, okay, which is 6.76. okay, so 6.76. okay, 156 over 20 minus 6.76, and the mean would be 1.04. okay, so it would be 1.04. okay, so that is the mean, and basically the standard deviation. So basically the standard deviation tells us that, let's say these are workers, right? So the workers, the salaries of workers, which are these 1, 2, 3 and 4, they differ at max by 1.04%, 1.04% plus minus the mean. okay, which means, let's say if the mean is 2, okay, so 2 is a worker's salary can be plus minus 1.04 of the mean. okay, I'm just assuming the mean to be okay, so we have the mean actually, so the mean is 2.6. okay, so 2.6, we will put it over here, 2.6, and every worker's salary would be between this bracket. It would be at max 2.6 plus 1.04, and minimum it would be 2.6 minus 1.04, and that is it for standard deviation. Thank you.